Rich Steeves on the floor at Cloud Expo 2012 Santa Clara. I'm here at the Clustrix booth. Joining me today is
Philippe Shemansky, the head of products at Clustrix.
Tell us a little bit about your company.
Great. So we are a venture-backed company, startup by Sequoia Capital, ATA Ventures, and USVP partners. We're basically a scale-out SQL database for big data applications, and we are available both on the cloud as well as an in-house cloud deployment via an appliance.
Tell us what you're showing here at the show.
Great. So we're basically talking about the complex world out there for data, including the pressures on a database in the market, such as big data, which is a lot of information, a lot of velocity on the data, as well as the complexity of development, which is now changing around Agile. So we have the challenge of frequent releases and the database keeping up with those changes, as well as the aspect of cloud, where they deployed the database and how does the database work in a private or public environment. The typical solution we have found that customers adopt when they don't know about Clustrix is they try to divide the data into many databases called sharding, or they seek out alternatives like NoSQL, where they recreate a lot of the logic of the application and the database basically in the application. So what we are looking at here is the logic moving to the application that typically wasn't a database and all the complexity that you have to now develop and manage. So what we do, at Clustrix, we take all the benefits of a relational database, such as SQL capability for the language, the ACID capabilities such as data integrity, durability, immediate consistency, and transactional capabilities, and build on that with a brand new architecture that is horizontally scalable, shared nothing, parallel computing architecture with fault tolerance built in, and is able to simply scale by adding additional nodes and capacity to the architecture. Now, how does it work? Behind the scenes, we ultimately lay down information across all the different nodes in the cluster by splitting the tables into something we call slices, and you can see basically slice 1, slice 2, etc. across all of them. And then what we do is replicate the information to the green ones to ensure fault tolerance. So if you lose one of the nodes, you don't lose necessarily the data, and then we reprotect the architecture and make sure there's more copies when failure happens. For queries, and that's where the parallelism comes in, any of the nodes can receive a query and process it, sending it to where the data is. Or if the query is more complex, there's a lot of joins happening, for example, we can take that query and divide it into query fragments, then distribute that across the cluster and allow basically parallel computing to happen and process more information at once and more concurrently than otherwise. In terms of the user experience, we have architected database to include over 2,500 metrics that are instrumented in the database from the ground up. That ultimately allows you to collect a lot of data like how it's behaving, how it's working, how are the queries executing, are there any bottlenecks for the application. So if you look over here on the screen, you can see that we have a lot of real-time statistics presented about the health of the application as well as the queries. And with Agile, we see a lot of interest around how did my code change the behavior of the database, and here we have the old code drop and the new code drop, and you can see the difference in the queries running, and if there's any queries that are problematic, you can address immediately with the developers.
Great, thank you so much for your demonstration.
Great, thanks a lot.